A Portland Community College Mathematics Telecourse. A course in arithmetic review. Produced at Portland Community College. This lesson is going to review subtracting signed numbers. If you are comfortable with the addition of signed numbers, then the subtraction of signed numbers is already 3/4 learned, because subtraction is merely a special case of addition in algebra. Here's a formal definition of subtraction, so let's use it as an opportunity to learn to read algebra. Really, it's quite simple. First, the letters, as we've learned already, simply indicate some number, which now indicates signed numbers as well. And this means the opposite of that number called b. If you have a definition or an axiom in algebra which involves an equation like this, what we're really saying is this. If you are trying to do this problem, we'll tell you how to do another problem that's related to it, which has the same answer. So notice this problem has a subtraction, but this problem is an addition, which we know how to do, and an opposite, which we already know how to do. So this says, leave the first number alone, change the subtraction to addition, and the thing that followed the subtraction gets opposited. Or, in short, subtraction simply means add the opposite of that number which follows the subtraction. Now let's illustrate that with our starting problems. It's saying that subtraction means add the opposite of what follows, which is plus 3 now. Again, subtraction means add the opposite of the number that follows. Again, subtraction means add the opposite of the number that follows. Again, subtraction means add the opposite of the number that follows. And of course, if we've learned the previous lesson well, we can now subtract very quickly by simply changing every problem to an addition problem, which we can do. This number, hopefully you'll realize, is simply -5. This one, -11. This one, +11. This one, +5. See what we meant by saying that subtraction is nothing more than a special case of addition? And if you can add, you can now subtract. Again, 4 more problems. Subtraction means add the opposite of what follows. Now that we're adding, if the signs are different, we take the difference, which is 16, and give it the sign of the one with the larger absolute value, which is negative. Again, subtraction means add the opposite of what follows, and 3/4 plus 1/4 is simply 1, +1. Again, subtraction means add the opposite of what follows. That what follows is an important phrase. Okay, since they're both negative, I add the absolute values and give it the like sign, negative. Again, don't be tempted to think that this is 0. Check it out first. Subtraction means add the opposite of what follows, and of course 7 plus 7 is +14. See, subtraction is that simple if you're good at addition. Now let's use our addition and subtraction skills to review our algebraic equations, which we've been encountering in almost every other lesson. Remember, if you have something being added to the unknown, you undo it by subtracting. But now what I'm really going to be doing is subtracting a -3. But notice with the signed numbers we have a little bit of latitude here. Instead of saying subtract -3, which is certainly correct, what we know about subtraction now, subtraction means add the opposite. So in fact I can think I'll add the opposite of that which I want to undo. But then I must add an equal amount to the other side. But now by adding 3 I'm really subtracting a -3. Okay, so this undoes this because 3 plus -3 is 0, leaving me with my variable m. And now we're going to add 3 to -8. The signs are different. Take their difference, which is 5. This has the larger absolute value, so we give it its sign. So the variable is -5. So in solving equations now with signed numbers, we do nothing different except be careful when we're adding or subtracting signed numbers. Now another one. We could think that to undo subtracting a -2, I'll add a -2. But also using the definition of subtraction, we know that subtraction means add the opposite of what follows. So our equation really is saying in another sense r plus a +2. And to undo adding, I will subtract negative or subtract 2. So if you have +2, subtract 2, you've undone the addition and you're back to your variable. But if I subtract 2 here, I must subtract 2 here. But that's the same thing as adding a -2. So you see, we can treat this subtract 2 as simply adding -2 because they're one and the same thing. And of course a -2 plus a -8 is -10. So after a while you'll begin to think of this subtraction 2 as simply adding a -2 and go ahead and add. Another one, to undo subtracting a number, you add the same number. That undoes that, leaving my variable. Now if I'm adding a positive to a negative, I take their difference, which is, this has the larger absolute value, so I give it its sign, which is plus, which I won't bother writing. Another one, to undo adding, you subtract from both sides. This undoes this, leaving the variable isolated, which is what we mean by solving the equation. Now, we've just said instead of thinking subtract 18, think add -18. So I'm adding a -18 to +5. The signs are different, so I take the arithmetic difference. This is the larger absolute value, so I give it its sign, which is minus. Again, another just somewhat messier. Recall, if you don't like the subtraction, subtraction means add the opposite of what follows. But now, to undo addition, I will subtract 1/2 from both sides. That undoes that, leaving my variable. Now I can think either 3/4 minus 1/2 or 3/4 plus -1/2. That's the same thing. Now, of course, this is -2/4. So 2/4 from 3/4, or adding -2/4 to +3/4 is +1/4. It takes a bit of practice, like golfing or playing the piano. You need about 20 or 30 or 100 problems to become very smooth. But it's not at all hard. This and future lessons will become and remain remarkably easy if we can simply nail down some very basic, simple facts. The first in this lesson is that subtraction means add the opposite of what followed the subtraction. So that if I had, let's say, a -5, minus negative 8, you would simply think subtraction means add the opposite of what followed, which is negative 8, and hence it becomes positive 8. And then we must assume at this point that addition is almost an automatic response, that you just look at these two and say, of course, the answer is positive 3. So if you know how to add and it's immediate, and if you know the simple definition of subtraction, you realize that in fact in algebra we don't really subtract. Arithmetically we do, because we certainly took the difference arithmetically between these absolute values. But algebraically, everything boils down to addition up to this point. Then, since the use of algebra is primarily concerned ultimately with solving equations or solving scientific business problems, we're concerned about solving equations. So let's take one more look at the techniques of solving equations relative to adding and subtracting. Many lessons ago we began with the simplest kind of equation where we have only one variable and we're adding something to it, whatever it is. I used a question mark here to indicate this could be any number, and we want it to be equal to any other number, now positive or negative. We tried to get across that the idea of solving equations is sort of a symbol pushing game, that we're trying to, by legal moves, to change this equation into another equation where this side, which we call the left member, has only the variable. And then whatever ends up on the other side we call the solution to the equation. Indeed, that's what it's telling us. This equal means is, so it's saying x is something. Our problem then was, how do we undo adding anything to get right back to the single variable? And we learned that to undo adding, you subtract the same quantity. But to make it legal in our game of solving equations, we have to remember that whatever I subtract from one side of the equation, I have to subtract the same amount from the other side of the equation. Hence, we've reduced this side to a single variable, which is the objective of the game. And on this side, we simply do whatever arithmetic is involved, and we're done. An example. Here we're saying some number, and that's what a variable stands for, simply the phrase some number, added to 144 is the number negative 292. To solve for that means what is the replacement for the variable that would make this sentence true. Well, we've learned from the statement up here that to undo adding, we subtract, in this case 144, so this undoes that, getting me down to simply a single r. But if I subtract 144 from this member of the equation, I must subtract 144 from this member. And now, from our definition of subtraction, subtraction simply means add the opposite of what follows. And since we have like signs, we simply add their absolute values. And of course, it will keep the like sign. Simple. Subtraction undoes adding, getting me to the variable. But whatever I subtract, I must subtract from the other side, remembering that subtraction means add the opposite of what follows. And we're done. When you get into algebra proper, you will see the immense value of this. So great that all of that which we call modern science, technology, space age, none of it is possible without this as a beginning point. Let's do one more. Again, notice how I changed the variable. Eventually, you'll simply pick that variable which will help you remember what you're talking about. M could be money or momentum. A could be acceleration or amount. But you simply think, to undo adding 50, I subtract 50. That will undo adding 50, and get me to the variable, which is the objective of our equation solving game. But the rule in playing the game says, fine, you may subtract anything you want from this entire side, providing you subtract the same amount from the other side. Then you simply go follow through on the arithmetic on this side. Subtraction means add the opposite of what follows, and we can immediately see in this simple case the solution is negative 20. You can see if I put it back into the original equation, replacing m by negative 20, that negative 20 plus 50 is 30, which is what I want it to be. So get used to playing the game, the simple games first, then on into algebra. We'll mess the game up a little bit by having variables on both sides and having many operations on both sides. But essentially it'll be just more of this done in pieces. And then in more advanced algebra, when you're good at playing the game, we can finally show you what the game is used for in business, science, astronomy, or any aspect of the technical business world, and it will truly be amazing and fun. But also remember that if we have an equation where from the variable something is being subtracted, whatever it is, we don't care. And of course we've got something over here, and we don't care what that is either. To undo subtraction, we add the same amount. But then the game playing rule says, fine, add anything you want to this side, but simply remember to add the same amount to the other side. So adding something undoes subtracting the same amount, reducing me to my single variable. An example. See, if we read this, it's not quite so obvious, is it? What number can I subtract 42 from and end up with negative 19? That's not at all obvious. However, to undo subtraction of 42, we simply add 42. But whatever I added to this side, no matter how big or how small, I must add the same amount to whatever is on the other side. So adding 42 undoes subtracting 42, getting me to the single r, which is what I wish. Now we simply perform the addition here. So adding unlike signs tells me to take the difference, smaller from the larger absolute value wise, and give it the sign of the larger absolute value, which in this case is 42. Simple? I hope so. Later, we'll begin to work problems like this, but recognize it's just more of the same but messier numbers involved, but the same principle. And then later in algebra, we'll begin to put more terms, multipliers, parentheses, where we'll have to use the order of operations, and we'll begin to put variables on both sides. But if you work these few simple problems we're going to begin to give you in this and the next 2 or 3 lessons, you'll find that by the time you get to here in algebra, this is just another logical, simple, additional step. Now is perhaps a good time to look at our calculators, particularly a scientific calculator, and see how it works with positive and negative numbers. First, let's see if your calculator has an opposite key. If it does, and this one does, on most calculators it will be a plus slash minus. That means when you push that key, and this doesn't focus too well on it, it will change the pluses to minuses and minuses to plus. So if I had a 45 on my calculator and push this key, it will change it to a negative 45. Do not confuse it with this key, which is subtraction. That's something entirely different. Although we can use it in a sense to duplicate for this when we're more experienced. Now notice, the opposite of negative 45 is positive 45. So if I were to push this again, it should take the opposite of that and make it into plus 45, and indeed it does. So if I wanted to take, let's say, negative 37 plus a negative 15, I would punch in 37, but I want it to be negative, so I push the change sign, so there's negative 37. Now add 15, but I want to make it negative 15, so change signs. Now equal, and let's see, we know if we're adding these by mind rather than the calculator, since I'm adding like signs, the answer will be negative, and add their absolute values, which would be 52. Let's see if the calculator knows that. So pushing the equal, I get negative 52. But notice, I could have looked at this a different way. Negative 37, but just as subtraction says to change the subtraction to addition by taking the opposite of what follows, I can change the addition back to subtraction by taking the opposite of what follows, and the opposite of negative 15 is positive 15. See, if we were going from here to here, it would be pretty obvious. Changes to addition, take the opposite of what follows. But there will be many times, particularly with a calculator, where rather than changing a subtraction to addition, you want to change an addition, at least mentally, into a subtraction. So this says 37, change signs, now subtract 15. So subtract 15 equals, and sure enough, the same results. Most calculators that you will purchase will have a change sign key. Some calculators, a little bit more expensive and a little bit fancier, like this semi-programmable calculator, will not only have a subtraction key, but a negative key. So if I wanted to enter in negative 37, rather than putting 37 in change signs, I can simply enter directly negative 37. Then if I wanted to add to that, let's say negative 19, then I would say add negative 19, and I would get negative 56. However, recall that we just said you can always change an addition, if you want, back to subtraction if you want to take the opposite of what follows, which is a plus 19. So this instructs me to take negative 37 minus just plain 19. And that should give me the same answer. So if we say equal, sure enough, it does. So if you have a calculator, read the instruction manuals very carefully to see how it takes negative numbers, or does it use a change sign keys, as does this one, which is perhaps the more common kind of calculator that most beginning students have. And certainly the calculator is a very handy tool when you're trying to add all of these rather messy decimal numbers, where maybe the negatives are debits and the positive are credits in a small business. But here on a calculator, we simply start with 22.5. Don't need the 0, it's already there. Change signs, so I go to my change sign key, now it's negative. Okay, now I want to add that, so add 19.3. Now rather than adding a negative, I'll simply subtract a positive. So you see, we can begin to treat these negatives as subtraction if we know that we're adding the opposite or subtracting the opposite. So in this case, I will subtract 48.15, which is the same as adding a negative 48.15. So now, subtract 9.07, add, because there's a positive, 17.52, add, because it's positive, 1.06, subtract, because it's negative, 15.23, equals, and see, the calculator gave me a negative number. However, you see I made a mistake because I should not have this many decimal point places, so somewhere along the line I punched the wrong key. So I've just redone it. And this is the point to remember about calculators. Calculators do not make your work more accurate. See, we just made a mistake on our first addition. I've redone it now, and I believe the answer will be negative 57.07. All a calculator does is help you to do arithmetic faster. It does not make you more accurate, because it's just as easy to punch a wrong key as I did just a moment ago as it is to make arithmetic mistakes in the mind. The advantage of a calculator, of course, is it's so fast that I can do this 2 or 3 times on the calculator while I'm doing it once mentally. So in the end, it's not a question of whether one should use a calculator or be able to do it by hand. In the end, to be a good business person or a mathematician or scientist, you must be good at both modes of arithmetic: calculator, by hand, and ultimately the computer as well. And of course, realize that most calculators won't do fractions. You have to do that by hand. A good exercise on this lesson is to do your work by hand, then check on the calculator. In that way, you're practicing both at the same time, and that's a very good exercise. And with very little practice, you can begin to solve equations mentally with a calculator. You know I'm going to have to subtract this to isolate the k, but then I have to subtract it from the other side. So on my calculator, I enter the 109, then the change sign key. Then I make the algebraic decision to undo this. I must subtract 213, so minus 213 equals, and there I have my k is negative 322, and I'm done. Practice this. I think you'll enjoy it. Until the next lesson, in which we will learn to multiply sign number, this is your host, Bob Fennell, saying, we'll see you then.